The first thing I want to do is I want you to look at this right here, please. And I want you to think about this for a quick second. All right? The question is, if you toss 3 coins, how many outcomes are there? If you toss 3 coins, how many outcomes? 6. You were going to say 6. 6. Yeah. Now listen, most people think there are 6. Now I'm going to try to show you, I'm going to try to demonstrate to you how this person figured it all out. All right? And when people can organize their thoughts, or when people can organize their data quickly, it's because they paid attention right now. All right, that's how important I think this is. All right, most people cannot list out all of the possibilities for flipping 3 coins because they don't visualize it very well. Now I'm going to show you how to visualize all of the 8 different possible outcomes. All right, the biggest mistake people make is they think there are 6. So now, what I want you to do is look up on the board. I'm not even asking you to do anything on your iPad right now. I'm asking you to look up here on the board so I can show you. All right? Now, again, we're flipping 3 coins. All right, I'm going to flip the first coin. All right, when I flip the first coin, now, the first coin, you don't have to write anything down. All you're doing is paying attention. Your first coin can be flipped, and you would observe that the only possible outcome is a head or a tail. Now you're going to flip the second coin. When you flip the second coin, the only possible outcome is what? Heads or tails. So now we're branching off. And then we're branching off here. You don't write this down. Just pay attention. So someone tell me now how many outcomes are possible if you flip 2 coins? 3.
4.
How many? 4. Now watch how I list them out so quick. Look up, please, and see if you can follow my pattern. You can flip head, head. You can flip head, tail, tail, head, or tail, tail. All right, those are your 4 options. But most people can't do that. All right, that's why a tree diagram is very beneficial. So when people can list things out quickly, it's not that they're randomly doing things. They're doing it in a certain what? Order. Now watch how I did this. Come on now. I want your eyes up so you can pay attention to what I'm doing. I don't want you looking at your iPad. I want you looking up there. Because in a minute I'm going to ask you what are the possibilities for 3 coins, and you're going to zip it out to me. All right? So your choice is head, head. Your choice is head, tail. Your choice is tail, head. Your choice is tail, tail. Everybody see what I tried to show you? Right? That's how people can sequentially list things out so quickly. And sometimes it appears that it's random, but guess what? It's not. It's not. All right? So now I'm going to flip another coin. All right? Now when I flip the third coin, what are my possibilities for my third coin? It's either what?
Heads or tails.
It's either heads or tail. So now here, heads or tails. Here, heads or tails. Here, heads or tails. And finally, your last choice, heads or tails. All right? Now, instead of saying heads, 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 I want you to just say HHH or HTH or HHT. But you're going to list out all the possibilities. All right, who's going to list out all 8 possibilities quickly? Give it a shot.
Head. Oh wait.
Just say H.
T.
No.
No, I know.
Go.
H.
What? You're not even looking at the board.
I did.
What?
H.
No. No. What? You know?
Well, I was going to do.
Oh, I know.
Tell him, Hanson.
H T H T H H T T T H T H H T H T T T H T T T.
That's it. No, look, man, you made a mistake or I would have said no. Simple as that. I'm following along. All right? Now, some of you, like I said, I could tell you're not listening very carefully because I asked you to do something, you had no idea what we're doing. You start randomly saying letters. You understand? That seemed, for the average person, just random. Do you agree? People just start saying T's and H's and H's and T's, and you're going, what in the world? Right? Because you're not following the pattern. So again, this is what I'm trying to show you. Your possibilities for the first flip are what? Heads and tails. Then the second flip off of this, heads, tails. Or what? Heads, tails. Your final flip can either be what? Heads, tails, all the way down. Now, if you want to count here, look. Here's what you're looking at. Hunter, come on. 1, 2, 3, 4, 5, 6, 7. There are 8 possible outcomes. The question is, what are the outcomes? Carly, I'm right up here. My outcomes are what? Here's what Hanson did. Here, here, here. Then he went what? Here, here, and then tails. Now, there was nowhere else to go up. So he now had to go, instead of going up, he had to go heads, tails, and then what? Heads, then heads, tails, tails. And then he was all done with all the possibilities of flipping a head first. Now, you're going to flip a what? Flip a coin and tails are going to come up. So your choices are what? T, H, H. Or T, H, T. Or T, T, H. Or T, T, T. That's what I'm trying to get at, guys. That's how people organize. All right? When you write something out sequentially, you never just randomly do it. There's a pattern to all of it. And this is what we're trying to demonstrate today. All right? Now the question is, how did we come up with those 8 rather than count 1, 2, 3, 4, 5, 6, 7, 8? So here's the secret of how I determined that there were 8. How many coins did we flip?
3.
So the first thing I want you to do now on your paper is we have 3 possibilities. That's what I need you writing down. If I have those 3 possibilities, how many outcomes are possible for a flipping a coin? How many outcomes? 2. 2, right? My second coin, how many outcomes are there? 2. My third coin, how many outcomes? 2. Now, most people said 2 plus 2 plus 2 is 6. But it's not. It's 2 to the third power. Or, listen to me, this is called the fundamental counting principle. You always multiply your possibilities. So what does that mean? That means 2 times 2 times 2 is what? 8. That gave me 8 possibilities. Now, does it list out the possibilities for you?
No.
You have to do that.
But then again,
You have to figure out the possibilities. All right? Now, what I'm trying to demonstrate here is I'm trying to show you how you can list out the possibilities, not in a random way, but in a what? Organized way. All right, that's what I'm trying to tell you. All right, is everybody with me? All right, so now I'm going to take a look at the next question. All right, and we're going to draw a tree diagram for the next one together. All right, it says this time a number cube is rolled. Well, a cube has how many sides and how many numbers? What are the numbers?
1, 2, 3, 4, 5, 6.
All right, so basically what we can do is we can roll a 1, a 2, a 3, 4, 5, or 6. That's what I want you writing down first. Those are your outcomes for when you throw the dice. Everybody agree with that? Now, you're going to toss a coin. That's your second event. All right, and you can get a what? You can get a heads or a tail. So now, next to the 1, you draw a little branch out. And you can say it can be a head or tail. And then for 2, same principle. 3, same principle. 4, same principle. And all the way down. All right? So from that information, if you wanted to list out the possibilities quickly, you could list them out as?
Oh, so should I list them out? Okay.
Yes.
1H, 1T, 2H, 2T, 3H, 3T, 4H, 4T, 5H, 5T, 6H, 6T.
That's how people do things quickly. Do you understand that? They organize it. We just didn't randomly say things. Is everybody good on that?
Yes.
So there were how many possibilities here?
12.
There were 12 outcomes. All right? Or you could say,
Well, can you do
or you could say what? 6 times 2. Thank you. And then I'll answer your question. So there are 12 possible outcomes. Again, the problem is they didn't list out all the outcomes. All right? And that's what that tree diagram allows you to list out all the.
Do we for in the future do you have to do the tree diagram?
Yes, I'm going to. I'm going to ask you to draw a tree diagram. All right? And then I'm going to ask you to list out things. All right? And you're going to see how beneficial it is if you can learn that skill of writing all the different possible combinations. Like I said, not many people can do that because they never learn the what? They never learn the value of the tree diagram that shows you the different possibilities of the different outcomes. All right? So that's extremely important. And I would say it's very easy. Very easy. But most people make the mistake they add rather than do what? Rather than multiply. All right? So now let's see if I did a good job. All right? Now, a lot of people don't know about decks of cards. So let's just review that real quick. There are how many cards?
52.
How many colors?
4. No, 2.
2
There's
colors.
red and black.
Red and black.
Four
How many
suits.
suits?
4.
4 suits. And then each suit has how many different types of cards?
4.
15.
13. Right? Ace, king, queen, jack. Right? And then 2 through 9. Or 2 through 10.
2 through 10.
Yeah, 2 through 10. Is everybody with me? So each deck of cards has 52 cards. There are 13 different 13 different cards for each of the 4 suits. And there are 2 different colors, red and black, general. All right? So you would say there's 4 aces, 4 kings, 4 queens, 4 jacks, 4 tens, and so on all the way down to what? 2. All right? Is everybody with me on that? All right? Not everybody understood cards, so that's why I'm kind of reviewing. All right? Plus, I don't think it's really that in depth here. So it says, find the total number of outcomes if you're going to draw a card from a deck. There are what? 52 outcomes. That's exactly correct. 52 outcomes. All right? Now, How many different outcomes are there if you throw 3 6-sided number cubes? How many outcomes are there? How many?
216.
How'd you get that?
I multiplied 6 times 6 times 6.
That's exactly correct, guys. And what I want you to do, rather than write 216 down, is I would like for you to write this. I think this was very helpful for me. There were 3 events going on. Those were what the tick marks represent. Is everybody with me on that? And when you throw the dice, how many outcomes are possible? Bless you. 6. And 6 can be 3 times. Now, I like what he said about being 6 cubed, but I prefer that you say it's just what? 6 times 6 times 6. And we all know that that is 216 possibilities. All right? Is everybody good with that? All right, now, 1 coin is flipped 3 consecutive times. That'd be 8 again. Again, I would want you to write down 2, 2, 2. So that was 8. All right. Now, how many outcomes are there if you're going to flip a coin and roll an 8-sided dice? 16. Again, very simple. 2 times 8, 16. All right. Now, everybody try the next one. Don't say anything. Just try the next one. And then you'll understand if you get it right. We got more work to do if you get it wrong. So everybody try number 7. So if a sweater comes in 3 sizes and 6 colors, that means how many different sweaters are there? How many, guys? 18. Right? Again, 3 times 6, 18. All right. Any questions with that? All right. Now you go to a restaurant and you look up and you see 2 salads, 6 entrees, and 5 desserts. Everybody with me? There are how many different dinners? 60, I believe. Again, I would go like this and say 2, 6, 5, 60 different possibilities. All right? Anybody have any questions or concerns with that? All right, let's look now. Now we're doing probability, and we talked about probability. Probability is your success over the total number of outcomes. The total number of outcomes. All right? So what's the probability of drawing the ace of spades? True. There are 4 aces, but there's only 1 ace of spades. Perfect. 1 out of 52. Sorry. That's good. Anybody have any questions with 1 out of 52? All right. So now let's take a look at 10. It says a coin is tossed twice. What's the probability of getting 2 tails? I got 1/2. 2 out of 4. 1/2. 1/2. 1/2. 1/2. Oh. Okay, so see, this is why I'm tell me.
Wait, but it probably could take 2. Wait, but it could.
What do you think?
It's
It's
2
not
4,
1/2.
but I reduced down 1/2.
What do you think? Don't listen to everybody else. Just tell me what you think. 1/4 is exactly correct.
Good job.
1/4. Of course it's 1/4. It's not 1/2. All right, let's explain why. Let's explain why. So a coin is tossed twice. What's the probability of getting a tail? I'm asking you one simple question. What's the probability of getting a tail when you flip a coin? 1/2. All right? So you have 2 things going on. You're going to flip a coin. You're going to get 1/2. Now you're going to flip it again. What's the probability of getting a tail again? 1/2. Fundamental counting principle says, what do you do with those options? You
Multiply.
multiply them together.
Oh.
That's how you came up with 1/4. So you have a 1 in 4 possibility. Now let's just like say, well, that doesn't make so much sense to me, but I kind of am okay with that. So now let me show you the logic here real quick. All right, let's look. I'm going to flip a coin. All right, I can get either a what? Head or a tail. The next time I flip it, I can get a what? Head or a tail. The next time, still, head or tail. Those are the possibilities. So my possibilities are, you can get a head, H and then an H. You get an H and then a T, T and then an H, and then T and a T. So how many outcomes are there? How many outcomes were there? 4. How many of them were tail? Tail. 1 out of 4. Does everybody agree with me? All right. Hopefully you see that now. What?
Oh, so if it's TH, that doesn't count.
Why not? Why doesn't that count?
Because it's not two.
Exactly. You're
we're
only.
getting two tail. Oh, I thought they meant two separate ones.
All right. Here we go. Let's take a look at number 11 now. You want to draw the 6 of clubs. Since that's specific, it would just be what? 1 out of 52. All right. Number 12. Think about it for a second. Write down your answer. Tell me. What'd you get? 1/2.
I got 1/2.
1/3.
I got 2/3
2/3.
1/2.
Why 2/3?
because divided by 2, 4 over 6 divided by 2 is 2/3.
Well, read the question to me.
It's
Just stop.
4 or higher. Never mind.
So what's the answer?
It's 1/2
Why?
because it's there's 4, 5, and 6.
Yeah, 4, 5, and 6. So there's 3 possibilities out of what? 6, which is 1/2. That's how I want you to be thinking about it now. I don't think it's that hard now. All right, try the next problem. All right, see if you're doing better. 13. What's the probability that I roll a 7 on an 8-sided dice? I got 1/8.
I got
1/4.
7
1/4.
or 8. I got 1/4.
I got 1/4.
7 or an 8.
Right?
Yeah.
1/4.
It says roll a what?
7 or an 8.
7 or an 8 on an 8-sided dice. So instead of being 1/8, it would be
1/4.
Wait.
2 out of 8,
Oh, and it's in.
Which is 1.
and then you reduce it down to 1/4. Okay? It's not bad. Just have to read carefully. Nothing to it. All right, so let's check out 14. If you want to roll an even number on an 8-sided dice, I want you to tell me that it is. But first, how many options or yes, 1/2 is the answer, but I would like for you to say 4/8. All right, I want you to write the answer, and then I want you to reduce the fraction. 4/8 reduces to 1/2. All right. Now, 15. What's probably that I draw a club from a standard deck? What?
1/4.
Yes, but I would rather you tell me it's
13 out of 52.
13 out of 52.
You can simplify that.
And then that reduces to
1/4.
1/4. What?
Wait, I'm a little confused. How did you know this?
There are 13 clubs, 13 diamonds, 13 hearts, and 13 spades. Have you ever played cards?
Yeah.
Yeah, so that's what there is.
Oh,
All right?
it's like the real amount.
Yes. All right? Now, number 16. What's the probability that I rolled an odd number on a 6-sided number cube? This would be easy.
So it's 3, 6.
Exactly. 3 out of 6 reduces to 1/2. Very easy. All right. Now let's see if there's anything harder. A coin is tossed and an 8-sided die is rolled. What is the probability that the coin lands on a tail and the die lands on a 2? What do you think?
Do you have a tissue?
What?
I got
1/16. Again, let's take a look at it just to make sure you understand what we're doing. All right? When you throw a coin, what's the probability that you get a tail? 1/2. So everybody put a 1/2 down. And then what's the probability that you land on the number 2? 1 out of 8. Fundamental counting principle, just multiply those together so you would get 1 out of 16. All right, is everybody kind of getting the hang of it? It's not that hard. All right, let's try 18. A coin is tossed. What's the probability of landing on tails?
tails, that's 1/2.
1/2. What's the probability of getting a red card?
1/2.
I know, but I prefer that you say 26 out of 52. I know on a test, if you want to put 1/2, I don't care. I'm just showing you right now, for the interest of just knowing the information, there are 26 red cards out of 52. Now, if you want to reduce, that would just be 1/2 times 1/2, which is 1/4. All right? So the probability of getting a tail and choosing a red would be 1/4. All right? Is everybody okay with that? All right. Now let's see if I've done a good job. All right. If I've done a good job, the homework problems shouldn't be so bad. Uh-oh. Number 1, I want someone to read that. I want someone to try to tell me what they think the answer is. Tell me.
Joan randomly dials a 7-digit phone number. So
How many outcomes are there?
because that was a 7-digit phone number. So would you for the 7-digit it would be you choose like 1 through 9. Those are
I just want to know what the answer is. What is the answer?
7 or
What
7
do you
10.
think?
7 out of 10. Maybe. Wait, no, I don't think that's.
I'm not asking for a probability. I'm saying how many. If you
How
have
many outcomes?
how many outcomes are there?
Oh,
What?
7. Or no.
49. What do you think?
I think my calculator is struggling.
7.
What?
I think.
70.
Oh yeah, 70.
Did not do a very good job.
1 out of
Isn't
70.
Isn't it 9
not a
to the
probability.
7? No, is it 7? 9 to the 7?
Very close,
Or
man.
7 to the
Thank
9?
you for listening, but that's
Oh.
almost correct.
60.
Stop. All right. Listen. Okay. So how many numbers are we selecting?
There's 10 numbers.
I'm just asking how many numbers are we selecting?
7.
7.
Oh,
7.
From the phone.
That's what I'm saying. Listen to me. We're selecting 7 numbers. 1, 2, 3, 4, 5, 6, 7. Now, Miles, tell me how many numbers can we choose from?
10.
10.
Oh, that's why my calculator.
Because you're choosing 0 through 9. There are 10 digits,
And then
right? So this would be a what? 10.
9.
This would be 10. Stop telling me it's a huge number. If you can't tell me what 10 to the 7th power is, you're way behind.
It's 10 million.
10 million. How do I know that? Because what's 1 times 1 times 1 times 1 times 1 times 1? 1. How many zeros do I need? 7. Because there are how many zeros there? 7. 1, 2, 3, 4, 5, 6, 7. So there are 10 million different phone numbers, right, that are 7 digits long. Now, does everybody understand why we had to do area codes? Because there are a lot more than what? 10 million people, right?
least
So they
7
had to introduce more numbers. Yes.
So, why wouldn't it be 9 numbers?
0.
0.
Oh, 0, my bad, sorry.
You know what I'm
I
saying? That's
I
a
didn't
common
know.
mistake. No, don't be sorry. That's a common mistake. Most people think 9. All right? Most people think 9. It's not a bad mistake. All right? But you have to remember, they're just the digits. There are 10 digits. 10 is not a digit. 10 is made up of what? 2 digits. All right? The digits that we use are 0 to 9. Everybody happy with that explanation? All right, let's see if we can do something else now. All right, now, give you 10 seconds. Shh. Everybody tell me the answer in 5 seconds, the answer to number 2. Ready?
Oh, I got it.
And Carly, I'm waiting for your answer to number 2. $300. Perfect. 300. Again, I would prefer that you have what? Does everybody see the 4 little tick marks I put up there? And then you should put down 5, 4, 5, 3, multiply them all together. That's how I got to 300. All right, now, as I'm trying to help some of you guys who want to do better, I need everybody to try number 3. Everybody on what? Why are you confused? Did you try 5 times 4 times 5 times 3? And what did you get? That's what I thought. Okay, so now I'm trying to speak to the people who I want to do better. Guys, you should try number 3 on your own. If you get it right, that means you understand. If you get it wrong, that means you have to ask me a question. All right, that's the new game we're playing. You try number 3. I'm going to tell you what the answer is. If you get it right, you understand. If you get it wrong, you have to ask me a question. All right, so everybody put down the answer for number 3. Did you put the answer down for number 3? Hurry up, let's go. Write an answer down. Alex, you got an answer for 3 yet?
I got one. I do.
5 more seconds. Shh. Now, 3, there could be multiple answers, actually.
Yeah.
All right? What do you think the answer is?
I said 1/52.
Yeah, 1 out of 52 is what I thought.
Or you could do
Yeah, that's what I thought.
400 plus.
1 out of, 208 would be an acceptable answer. Just listen. Or you could say 4 out of 208. And 4 out of 208 reduces to 1 out of 52. Now, there's arguments on both sides. All right? Does everybody agree in each deck there is 1 ace of clubs? If you put them together, there are now what? 4 ace of clubs. All right? So I'm just simply saying I don't really think it matters, but it's just your interpretation, and I'm not going to make a big deal of this. If you said 1 out of 52, pat yourself on the back. If you said 1 out of 208, pat yourself on the back. All right? I think it's a possibility, because are the ace of clubs the same in each deck? I would say yes.
Yeah.
But they do say there are 4 different what? Decks. So you might have like a green deck, you might have a yellow deck, you might have a white deck, and you might have a gray deck. Does everybody see what I'm saying? So are the ace of clubs exactly the same? No. So if you wanted to say 1 out of 208, I would be totally fine with that. If you said 1 out of 52, I'm like you. That's the way I'm thinking. An ace of club is an ace of club. Doesn't matter what deck you put it in. Does everybody agree with that? So I said it's 1 out of 52. If you said 1 out of 208, you're thinking very well also. Now, who doesn't understand what I'm saying? That's your job. Speak up. What?
So anyway, we got 1 out
That's exactly what I said. All right? You could have 1 out of 52 or 1 out of 208. Those are your options.
But I thought we were counting
Well,
the
that's right.
outcomes, not the percentage of getting a certain, or the odds of getting a certain card.
That's why it would be 4 out of.
No, I thought we were counting the outcomes, so it would either
Yeah,
be
we're doing
52 or 208.
Oh.
Yeah.
You know what? Listen. I think. Yes. There is. So listen to me. You are correct. You're just interrupting me. All right. I think there are 208 outcomes. Right. I think that's the better answer here because it's not what? It's not asking for a probability. All right. It's not asking for a probability. Right. It's just saying how many total cards are there. 208. All right. So thank you, Miles. I think that does clear it up. Listen, you have to go back and read the directions here. Find the total number of outcomes. That's just saying how many cards are there. 208. Everybody with me on that? All right. So again, I'll make that clear. All right. Now, question number 4. It says a store offers running shoes with either extra stability or extra cushioning from 4 different manufacturers. How many outcomes are there? How many outcomes? 8. Exactly. They're coming from what? 4 different places. You have 2 different options. So 4 times 2, which is 8. Very good. All right. Now for number 5, it says a winter sweater comes in wool or fleece, a zipper or a crew neck, in 3 different colors.
I got 12.
So the answer would be 12. Everybody happy with that? Because again, you have 3 options here. You have 2 different types, you have 2 different possibilities, and you have 3 different colors. Fundamental counting principle, just multiply them together. So there are 12 outcomes. All right. Now, you have 1 spinner can land on red, green, blue, or yellow. Another can land on right foot, right hand, left hand. How many outcomes are there?
I got 16.
Does everybody agree with there being 16 outcomes?
Yeah.
Allison, you good with that? Kate, you good with that? 16 possible outcomes because it was 4 times 4. Right?
Yeah.
Okay, so now we're getting into the probability part. All right? What is the probability that you get a 4 or lower on a cube?
I got 4 out of 6.
4 out of 6. That's what I want you to do. 4 out of 6, and then reduce it to 2/3. 4 out of 6 and reduce it to 2/3. Yes.
So when we have a problem that is a number cube, it's always a 6.
Unless they tell you. Okay. Number 8. It says a number cube is rolled. What is the probability of getting a 5 or higher?
I got
2 out of 6.
1/3.
And then we're going to reduce it to 1/3. Now, number 9. An 8-sided die is rolled. All right? And a coin is tossed.
I got
What is the probability of landing on an even number? So what's the probability of landing on an even number, Hunter? I know, but I prefer that you say what? 4 out of 8 times, and then getting ahead would be what? 1/2.
4/16.
And then you would say 1/2 times 1/2 because I'd like to reduce it. So it'd be 1/4. So Hunter is not wrong when he just automatically said 1/2. I'm just simply trying to write all the work so if you have a question, you can understand where the 1/2 came from. The 1/2 came from the fact that 4 out of 8. All right? Now let's look at number 10. It says a coin is tossed and a card is drawn. What is the probability of landing on heads? What's the probability of landing on heads? Come on.
1/2.
1/2. And what's the probability of choosing a heart?
13.
13 out of 52. So now we have 1/2, which is 1/8. Is everybody following along pretty good? All right, let's check out number 11. How many fruit smoothies are possible from 6 choices of fruit, 4 choices of milk, and 3 sizes? 72, right? Again, I would probably hope that you would write 6, 4, 3, 72. All right, so your job now tonight is to try 12, 13, and then try the ERB questions.
1 and
All right, 1 through 6. All right, try to finish up 12, 13, and then 1 through 6. I'm going to take a look at your homework tomorrow. Make sure you did a good job.
what was